Hey everybody, Matt Morgan here. In this lesson, we're going to talk about molecular structure from OpenStax section 7.6. What we'll do in this lesson is we'll transition from electron pair geometry from the last lesson to molecular structure here. We'll see molecular structures for each electron pair geometry. Also, I'll be using the PhET simulation to draw pictures of all of these structures. There is the link, it is also in the video folder, and you should use this simulation to see these structures yourself. So electron pair geometries, that's what we did last time. The repulsion of electrons around the central atom, those gave us the bond angles for a particular molecule. Now we will see the influence of lone pairs to go from electron pair geometry to structure. If the molecule contains non-bonding or lone pairs of electrons, the molecular structure will be different than the electron pair geometry. Remember, non-bonding electrons are still considered a region of high electron density. They repel, just like single, double, and triple bonds. So repulsion occurs even if there's not an atom there. The repulsion is from the electrons. So sometimes it doesn't matter where the lone pair is located, but sometimes it does. We'll go through these individual structures so you can see. So the overriding rule as we go through all of these, it may seem random, but it's not. The electron pairs want to be as far apart as possible, and they will adopt a structure in order to do that. We'll go through all the geometries, determine the structures based on different numbers of lone pairs. There's the overall table. There's a lot of information here, but we will go through the electron pair geometries one at a time. Let's start with the trigonal planar electron pair geometry. That's 3 pairs. That's 3 electronic regions around the central atom. Our bond angle is 120 degrees. If we have one non-bonding pair, then the structure is bent or V-shaped, and the bond angle is still about 120 degrees. That's what the structure looks like. On top is the lone pair. It repels just as if there were an atom there. In fact, it repels a little bit more. The bond angle is actually a little less than 120, but on an assessment, if you say 120, you will be fine. Let's move on to tetrahedral electron pair geometry. 4 regions, 4 electron pairs around the central atom. If we have one lone pair, the structure is trigonal pyramid. The adjective part of that is trigonal pyramidal or pyramidal. Bond angle 109.5. If there are 2 lone pairs, then the structure is bent or V-shaped. Notice how the lone pairs repel, and it kind of sort of looks like a tetrahedron, only there are no atoms in the lone pair positions. This is the structure of the water molecule. Bond angles around 109.5. The trigonal bipyramid is next. 5 regions, 5 electron pairs around the central atom. The molecules start to get busy when there are 5 groups around the central atom. Also, for this electron pair geometry, notice the different bond angles, so it does matter where the lone pair is located. One lone pair appears at the equatorial position, and we call this structure seesaw. Notice that the equator position has 120 degrees to roam. Those electrons want to be as far apart as possible. That's why the lone pairs are at the equator and not at the 90-degree axis. If there's a second lone pair, it's also at the equator. We call that a T-shaped molecule. You can see the atoms adopt the T-shape. You can see the lone pairs in the equatorial position of the trigonal bipyramid. If there are 3 lone pairs, they will all be in equatorial positions. That 120 degrees has more room than the 90. Lone pairs repel more than bonding pairs. There is our structure. It's linear, with the lone pairs around the equator and the atoms in the straight line position. Finally, we'll talk about the octahedral electron pair geometry. Lots going on here, lots of opportunities for different numbers of lone pairs. So one lone pair, we call that a square pyramid because all of the positions are 90 degrees, they're all equal. Where the first lone pair appears, doesn't matter. We get a 4-sided base to our pyramid plus the 5th atom makes the top part. That's our square pyramid. Bond angles, 90 degrees. If we have 2 lone pairs, this will adopt the square planar structure. That second lone pair will be opposite the first. Remember, lone pairs want to be as far apart as possible. We have 4 atoms around the central atom adopting the square shape, and they are in the single plane. The second electron pair must be opposite the first. If we have 3 lone pairs, that's a T-shape. Bond angle's 90 degrees. 4 lone pairs, like the trigonal bipyramid, that will be opposite of the previous lone pair. That will be a linear molecule. Okay, bond angles all 90 degrees except the linear. Of course, the straight line is 180. Lot of information in this table. We went through quite a bit. So how do you know it all? It does seem like rote memorization, but the structural names are intuitive. T-shape, square planar. If you practice, you can master this concept. If you have molecular model kits, that's a great way to practice. Also, use that PhET simulation so you can see the 3-dimensional shapes as you add lone pairs. You also have your 3x5 card. So the combination of all of those, you should be able to determine the molecular structures based on the electron pair geometries. So here's an overview of what we've done so far. Lewis structure goes to the electron pair geometry. Electron pair geometry gives us the bond angles. Electron pair geometry also, if we apply lone pairs, gives us the molecular structure. From the molecular structure, we determine whether or not a molecule is polar, and that's another video later. So we saw molecular structures based on all the electron pair geometries. Next video, what we'll do, we'll apply what we learned and work homework problem number 93. So the final video, we'll talk about polarity, taking all that we learned. There's my email. We have online office hours Tuesday and Thursday mornings, 9 to 10 a.m. And you can make an appointment if those times don't work for you.